Hi, we're going to do Year 10 Metals, and this first question is just going to be 5 marks, but it covers reactivity as well as displacement of this chapter. Now, with this chapter of metals, you would need to know and remember, basically memorize it, the reactivity of metals, and this is how it will look like, okay? So if you look at the the right hand side of the screen, okay, you will be able to see the reactivity series of metals, and it starts from potassium all the way to gold at the bottom. Now in this series, there are two things to take note of. That we have these two that's highlighted in yellow. They are technically our non-metals. I'm going to use green over here. Non-metals, they are the carbon as well as hydrogen. Okay, they are placed there for different reasons. So the carbon is there to remind us of how we can reduce metal oxide. Basically how we can extract metals from their metal oxides. Say for example, if I want magnesium from magnesium oxide, okay, I can't use carbon to extract it because carbon is below it, so I have to use electrolysis. Okay, so that's the purpose of the carbon over here. But the one at the bottom, which is our hydrogen, the non-metal at the bottom, hydrogen here, allows us to differentiate, okay, which metals are considered unreactive. Basically, the unreactive metals are our copper, silver, and gold, so they would not be able to react with acid. Okay, so the two non-metals are over there to kind of guide you on different reactions. Now, this one you need to know by heart, so devise a mnemonic. Mnemonic is a memory technique to help you remember potassium all the way to go at the bottom. Okay, so with that in mind, I'm going to take away my green color wording so it minimizes the confusion with the main question that we have over here. Let's dive into the first question, shall we? So we have here, I'm going to put this on the side, okay, and sorry. We have a reaction of metals with water as well as dilute sulfuric acid. So you can see that this table provides us two data, one with water and one with sulfuric acid. Now, let's look at the first column, which is with water. Okay, you will be able to see that which metal is the most reactive, right? With water, this is the first thing you should be looking at. With water, the one that reacts quickly, followed by a very slow reaction, is still considered reaction, okay? And you will be able to identify the most reactive metal here, just basically using reaction with water. So Z is the most reactive one. That means Z is the potential answer. So right now, although I've crossed out B as the answer, we're going to work backwards and prove to ourselves why B is the answer here. Okay. Next, so we can't tell anything between like W and Y because they both have no reaction with water. So we have to use the next column, which is reaction with sulfuric acid. So looking at the keywords, okay, so you see that violently would definitely means this is the most reactive, violent reaction with acid, followed by quickly. So the first two is still the same, right? Z followed by X. So just technically, just like that, you will be able to get your answer. But okay, let's look into the next one. Next one will be slowly, and then followed by no reaction. So the least reactive here would be our W, least reactive. Okay, so there you go. Just like that, you would be able to obtain B as your answer for this question. Okay, so you will want to, when it comes to this kind of question, don't assign any real metal to W, X, Y, Z. They are not real metals, but you're supposed to just use the data in the table to guide you. And basically, it is the keywords in the data to describe the reaction that guides you on the reactivity. Okay, next one. We're looking at the next question, which metal could be copper? Now, copper, if you take a look at the reactivity series over here, okay, copper again is our unreactive metal. Unreactive. So basically it has, and it's under H, so there's no reaction with acid. So if you look at the acid column over here, the one that has no reaction with acid would be our W. So it means that W would be the answer for copper. Okay, next state, which metal could be magnesium? Now, in order for you to work out this question, you will need to know something. Okay, so we have, again, I'm going to look at the reactivity series on the right. Okay, the one that I've just circled, okay, this one, Okay, the first four, they can react with water, but it gets slower and slower along the way. Okay, so you can see that magnesium can react with water, but it's the last one that can react with water, so the reaction is actually really, really slow. If I could pause this for a while and bring you to this video, okay, take a look at what happened.
Add the magnesium metal to some water. We notice that the magnesium metal sinks. Group 2 metals are more dense than water. We also notice that there's no apparent reaction between the magnesium metal and the water.
Okay, so it would not be immediate, but there will be some reaction. But of course, this reaction will be really, really, really slow. As compared to like if you put a piece of potassium or sodium in water, which I believe you would have seen in school, you will notice the difference in the reaction speed, right? So back to our question. So the question here is which metals WXYZ could be magnesium. So we are looking at something that can react with acid but really slowly with water. So it would be X. Okay, really, really slow reaction with water, and it reacts with acid. Okay, so X would be the answer here. Okay, the things to take note, or rather a common errors over here. Some students put Z as the answer. Magnesium don't react quickly with water, so it won't be Z. Okay. I wanted to talk about this question over here. Okay, the question before, going backwards a little bit. Okay, some students put Y as the answer for which metal could be copper. Okay, why is Y not possible? Is because copper metal would not be able to react with acid. Okay, so you do need to know not only this reactivity series by heart, but you also need to know what are the possible reaction for each of them. Okay, mainly in the syllabus, you need to know which metal can react with water and which metal can react with acid. So these two things first. But of course, if this is the first time you see this, then work on memorizing this metal reactivity series first. Then level 2 would be knowing which metal can react with water and which metal can react with acid. Alright, last question here, which is a 2-mark question. I'm going to use yellow. Displacement reaction can be used to decide the order of reactivity of 2 metals. So state 2 observation. Now, observation is basically what you see, okay, what you can see when magnesium powder is added to copper sulfate. Now, let's take a moment here to write out this reaction, okay? So I've got magnesium reacting with copper sulfate. And we're going to go back to the top of the reactivity series. Now I'm going to use, can I try to use pink to highlight? Okay, I'm going to use some other color that you have not seen before. Okay, this color. So I've got magnesium over here on the top, and then copper from copper sulfate, right, at the bottom. So magnesium is higher in the reactivity series compared to copper. That means magnesium is more reactive than copper. So what's going to happen here is this magnesium will be able to displace. The word we use is displace, where a more reactive metal takes the place of a less reactive one. So what we get at the end of the day is magnesium sulfate plus copper. So copper has been displaced. So what are the things that you would see? Okay, so first thing first, you will need to know that copper sulfate is blue, and this is a very common reaction or reactant in chemistry, so you do need to know that it's blue. When it forms magnesium sulfate, this will be colorless. Okay, so first thing first, the solution will turn colorless. If you want to be clearer, turn from blue to colorless. That is the best, okay? But if not, just writing that the solution will turn colorless will get you your marks, okay? Again, they do not accept the word clear. Okay, clear refers to whether there's precipitate or no precipitate, so it does not tell us the color, so don't use the word clear to replace colorless. They also will not allow magnesium to disappear, because in the question they mentioned there's an excess of magnesium powder already, so there will still be some magnesium being present in the solution. Then what is the next most common thing? It's the formation of copper. Now copper is a very unique metal because of this color. It is not grayish like the rest of the majority of the metals. It has this pink brown color that's attached to it. So at the end of the day, a pink brown solid is formed. So if I could pause and again go to a video to help you understand this. It would be this video here.
I switched from due dates to due date.
I wasn't planning for advertisement. There you go. Okay, so you put a piece of magnesium in there. You get to see this like powder that is descending down to the base of the test tube. This is actually our copper metal that is being formed. But thankfully this is a timeless video. I don't have to wait through the whole thing. I'm just going to... Can you see the difference in color of the solution? You start from something that is really bluish. Midway through, it turns a little bit greenish, right? Not so blue anymore. And towards the end, if you give it enough time, it would... Oops. The color change. I personally like this video better because I've always used this video in my class. Thanks to this teacher. Okay, so again we start from this blue, and after a while it will turn... Oops, this is another video, I think. Yeah, it will turn colorless. Okay, and the darker color solid that forms on the surface is actually, in this case I don't think it's copper. Copper would look slightly different. Copper would look... Maybe I'll find a better video that shows this pink brown. Okay, but the main color change that we have here is blue to colorless, and then because of the formation of copper, we would get the pink brown solid. Okay, right. So here we are looking at observation, so you don't need to explain why this is taking place, but if you need to see the equation, that will be the one in purple. Okay, so the blue color words are not allowed. That means in terms of color, for copper metal, we use the word pink brown to describe it, or pink or brown or pink brown. I personally like pink brown just to give me a differentiation in colors. If you use red or orange, there'll be no marks here, so take note. Okay, and things like that. Okay, things like that. Why is this answer, although it's correct, it is, you won't get any marks here because this would feed into a explanation question. Explain why this reaction takes place. The main idea behind this reaction is magnesium is more reactive. This over here is more reactive, so magnesium can displace copper from copper sulfate. So if this is a 2-mark explain question, then yes, this would be the answer. But for this question, we are only looking at observation, so there is actually no marks if you are writing out the explanation. So there we go. We have a 5-mark question here, but hopefully this 5 marks question help you see, or rather it's an introduction to reactivity of metals as well as the displacement. Okay, cool. First question. I think I'll see you in the next one.